Hey everyone, welcome back to the channel. Today we are talking about Paxos algorithm, one of the oldest and most well-known consensus algorithms in distributed systems. Paxos ensure consistency across multiple nodes, even in the face of failures. Okay, so why do we need Paxos? Why it is quite important? In distributed systems, data is spread across multiple nodes. When when we need a way to make sure all nodes agree on a single or consistent value or state like a database update or configuration change, network delays, or even node failures and partial update as well, all of this can lead to inconsistency. Where we That's where we need or when we need Paxos algorithms. That's where Paxos comes in, guaranteeing consistency guaranteeing consensus even when some nodes fail or act unpredictably. Okay, so let's try to understand how does it work. So we have a proposal or a leader, and we have the proposal itself, and we have the acceptance. First, it comes. This algorithm works in three phases. The first one is leader election. First, Paxos elects a leader, often called a proposal. This leader is responsible for proposing updates. Number two, we have the proposal itself. The leader will choose a value to propose and send it to the other node, often called acceptors. Number three, we have acceptance. If a majority of acceptors agree on that value, it becomes the chosen value. No other conflicting value can override it at all. The key insight is that you only need a majority of acceptors to agree before you consider the proposal as official. Okay, so in Paxos, nodes can play three roles. First, proposers, like say they suggest a proposed value for acceptance. Number two, acceptors by itself, which they vote on a proposal and value is chosen if a majority of acceptance vote is yes. And second, we have what we call let me make it like that. What we call like a learners. Like let's say that we have another node, we call it a learners. Learners, they observe which value was chosen and record it as the final result. Often these rules can combined in practice. For example, each node might be both proposal and acceptor in the same time. For example, okay, there is some basic phases of the Paxos algorithms that we need to talk about. The first one, we call it a prepare phase. The prepare phase, the proposal here picks a unique proposal number and sends a prepare request to the acceptors. Acceptors respond with the highest number proposal they have accepted, if there was any. And then second phase, we call it accept phase. The proposal uses that info to build a final accept request, including the highest proposal values learned. If a majority of acceptors say yes, the proposal is chosen. This ensures that once a value is accepted, any new proposal must respect previous accept values, keeping the system consistent. Okay, why the Paxos algorithm matters? Why it matters? Okay, there are three reasons. First, fault tolerance. Like if some nodes fails, Paxos can still reach consensus as long as a majority are operational. Number two, no single point of failure. Like the leader can fail, but Paxos will elect a new one. Number three, foundation of distributed systems. Many modern consensus protocol like Raft take inspiration from this algorithm, to be honest. Thanks for these properties, Paxos underpins numerous robots and highly available systems in industry, like Google's Choppy Log service or Azoro infrastructures. There are some challenges that comes with challenge. There are some challenges that comes with Paxos algorithm. Number one, complexity. Paxos can be tricky to understand and implement correctly, partly due to its multiple phases. Number two, performance. Basic Paxos may have higher message overhead through variants exist to optimize. Number three, leader overload. If the leader handles every proposal, it can become a bottleneck. Systems often mitigate this with load balancing strategies or more advanced versions of Paxos. While Paxos is powerful, it's not simple. That's one reason why algorithms like Craft came along to offer the same guarantees with a more understandable approach. Okay, so let's wrap everything up right now. That's it. Paxos in a nutshell. Consensus algorithms that relies on leader proposing various values and majority of nodes accepting them. It's a cornerstone of distributed computing, ensuring consistency even when node fails. If you found this video helpful or useful, please like the video, subscribe, and hit the notification bell so never miss any video. And see you guys in future videos.